this tutorial, I am going to show you how you can generate or plot ROC curves like this one. ROC curves or ROC curves are used for visualizing the performance of machine learning models. For this tutorial, I'll focus on binary classifiers. I assume that you have some knowledge about ROC curves. If you don't, I'll leave some useful links in the description box, so just use them to read about ROC curves and get a better understanding of them. Before we start the exercise, let me give a brief description of ROC curves. So a typical ROC curve will be like this, and then you have the false positive rate on the x-axis. False positive rate is also known as specificity. Okay, in some tutorials you also see FPR. They all refer to the same thing. The y-axis has the true positive rate, which is also known as the sensitivity. You can also find TPR being used. Okay, so they refer to the same thing here. You should also know that ROC curves are plots of probabilities. Okay, so in the course of this tutorial, we'll look at how to extract those probabilities and use them to compute the false positive rates, true positive rates, and then use them to generate the plots. So for this tutorial, the only requirement I want from you is to have an internet browser. Okay, that's all you need. And of course, you need internet connection. That is what we are going to use. We are going to run all the codes, all the example codes online. Okay, so let's quickly go. I have prepared the notebook on one of my GitHub repos here. Okay, so just also take note of this link here because we are going to use this link. I will leave it in the description box anyway. So I have some notebooks here. Yeah, these ones I will eventually move them to this folder. So the notebook we are going to use is in this folder, this notebooks folder here. So let's go there. I will just click it. So just go there. You will see this notebook here, ROC curves binary classification. That is what we are going to use. You can also download this notebook. It's just available for you to use. So just download whenever you want to. Okay, so we are going to run everything using an online Python platform called the Google Colab. So there's it. There's a page, and I'll leave the link to this page also in the description box. So Google Colab allows you to run Python codes using your browser. It's a cool platform that we have here. So let's proceed. So we are going to open this notebook, which is on GitHub. So I'll just show you how to do that with Google Colab. And before we proceed, let me also say that with Google Colab, you need to sign in with your Google accounts. It's important you do that. So once you sign in, you have access to the Google Colab platform. So just sign in. Okay, so once you are signed in, you have this page here. Just come to upload. No, not upload. Yeah, okay. Just come to GitHub, this particular one here, because we are running the code from GitHub. So you need to go to this side here. So GitHub, just click on GitHub. And then once you are here, okay, just paste the link, the GitHub link that I showed, my repo, which is this one here. Just copy this link. You only need up to the machine learning tutorials. I'll just check the description box. You find the link there. So once you have this, just click on the search. If you don't see anything here, just click on this search icon here. So once you search, you will have this popping up, this list popping up here. So okay, so this particular list here has all the notebooks I have in that repo, which is this one here. So just scroll down. You can use this particular scroll bar here also to scroll down. So scroll down until you see this one here, this notebook called notebook/ROC curves binary classification. That is what we are going to use. So let's open it. So just click it or double click, whatever you want to do, and then it will be open for you. That's what you need to note. Okay, so it's opened. So once it's opened, we are ready to start the exercise. Okay, so welcome to the machine learning course. Okay, now let's proceed. All right, so we roll. I made mention that ROC curves are used for visualizing the performance of machine learning models. So machine learning models, the performance are obtained during the evaluation stage. The evaluation stage is a later stage. Okay, so That one comes in after you've acquired your data, done processing, had your training, and then fed the model with the training subset. Okay, so this tutorial, even though the focus is on the plotting or generating of the ROC curves, I thought it wise to let you have a feel of how a typical machine learning work is. Okay, so I'm doing this so that beginners will have a feel of machine learning work and not just about the plotting, because the plotting comes in at a later stage anyway. So just stay put and let's proceed. So the codes have been written and I'll explain them as we move along. So we are using Python. So if you are going to use Python for your machine learning work, then you need to have your Python libraries, and that is what we have here. Okay, that's what we have here. So with Google Colab, a lot of these Python packages for data science and machine learning are already installed. So all that you need to do is to just import them as I'm doing here. So that will be the first stage, importing the libraries for the analysis. So let's run this. There's a cell. So once we are ready to run, we just need to come here and then just click on this button here just to run it. So just click it. Alternatively, you can use the control and then the enter keyboard to run the cell. So let's run it. So run it, and then once the codes have been executed successfully, you will see this here. Okay, so when the code, I repeat again, when the codes are executed successfully, you will see this green tick here indicating that everything is okay. So if you are running it for the first time, there might be some delays, but that should be fine. Let's proceed. Okay, so we have the libraries imported. The next thing to do is to get our data. So I have the link to the data I'll be using here. So the data set is also on the same GitHub repo, which is named Machine Learning Tutorials. So I'm using the PIMA diabetes dataset, which is very popular in the machine learning community anyway. So once you're on the repo, just look at this folder here. The data is there. You can download it as well. It's just there for you to use. Okay, so let's proceed. So it's the link of the data that I have supplied here. That's what we are going to use. So I'll just run this cell to get the link to the data. So I have it here. We will now read this data using pandas. So let me just proceed. So I have my pandas here, and there's the code for reading CSV file. So this data is a CSV file, and pandas can be used to read CSV file. So that is what I have here. One cool thing about pandas is that you don't necessarily have to get the data on your PC. You can supply it with the link. If the data is on a web server somewhere, you can just supply the link of that file to pandas and it will still read it. And that is what I'm doing here. So I'll just run this code just to get the CSV file. So it will be read to a data frame object. So I have it done. So there's a green tick. Everything is okay. So let's proceed. So with machine learning, if you have your data, it's important to explore the data, and also you need to clean and pre-process. So we will do a few of these things. I'll use this to also explain some few things for you. Okay, so I just stay put. I'll just explain the importance points here. Okay, so with exploration, obviously you need to have the number. You need to have the number of samples you are dealing with. So this code here will generate that for us. So let's run this to get the data. So we use the data frame .shape, and now we have 768 samples. That's what we have here. And we also have 9 columns. So this rows, this column. So that's what we need here. So take notes. You also need to understand your data, and that means that you need to also get the column names. Okay, so column names will give some descriptions of the content themselves. So it's important to get a column name. So let's just get it, and I will use that for the next step. So run this cell and then get your column names. Okay, so the PIMA diabetes data here comprises of 2 groups. We have one group which were diagnosed with diabetes, and the other group had no diabetes. And for these 2 groups, measurements were taken from them. These are the measurements. That is what you see here. And so that's what these columns here are for. And then the outcome. So these columns will give you the information that you need. So okay, so I will explain this data set later on. So I have the columns, so at least I know what I'm dealing with, which is good. So this will also let you know if some of these things have been misspelled or not, so that you can correct them, because we need to have a visual representation of whatever we are doing. With exploration, you can just sample and view some of the data sets. So pandas allows you to do that using this method here, .head, okay, and then .tail. So .head will let you read or obtain the first n rows of the data. So this command here will return the first 5 rows for that data frame which we have here. Okay, so just run this code to get the first 5 rows. So there we have it. Okay, so we are doing a great job here. Cool. So here you just need to just scroll through and just read. So here it's just like you opening the file with a spreadsheet software. So we just have it here with pandas, and that's cool. So we have the columns here, and notice the measurements and then the outcome. So we are good to go. With data exploration, it is important to also check the missingness. Do we have missing values? You need to get that information, because missing values sometimes may affect the performance of the model. So you need to understand and get it so that you can deal with them. So let's run this code to check the missing data, whether we have. Okay, so everything looks clean because there are no missing values here. That is why we see 0, 0 throughout. So it's good. Okay, let's get the different outcomes. Okay, so we'll use this code to get the outcomes. So let's run this here. Okay, great. So the outcomes are also referred to as classes or labels in machine learning. So that had this column name outcome. So we have 2 outcomes. We have 1 for diabetes, 0 for no diabetes. So we are dealing with what? Binary classification, because we have 2 classes here. So take note of that. With data exploration, it is important to also get a class distribution to know how many samples are there for each class or each category. So we run this code to get it. Okay, so that is also there for us. So we have 0, 500. That means those without diabetes, 500 of them. Those with diabetes, which is 1, 268. So with these values here, I'll say there's class imbalance. If you check this one here, the 0 here is twice, almost twice this one here. So there's a class imbalance. So class imbalance is something you also have to deal with or account for when using machine learning activities. Okay, so in machine learning, some methods factor in or take into consideration class imbalance, others too don't. So you need to make sure you have models or methods that account for or take care of class imbalance. There are ways to deal with it, but those are things I'll cover in later tutorials. Okay, we have the class distribution here, but sometimes, as the saying goes, a picture is worth 1,000 words. We can better understand and interpret the data if you visualize them. So let's do a plot of this class distribution here. So let's run this to get the distribution. So we have it here. Okay, so that is what we have. So at least from this, it's clear. The difference, what the difference is here. So take note. So 0, 1, okay, I think this one was just 10, but it doesn't matter anyway. So let's proceed. So with machine learning activities, you also need to do data processing. And one of the things that we do is to separate the features from the labels. Okay, so the features are the measurements and the labels or classes are the outcomes. At least I'm speaking in terms of this tutorial and this data set and how the columns have been named. So the features are measurements, the classes are the outcomes. So that is what we are doing here, to separate them. So we have the X and Y, and these are the codes to do this. So let's run this to get that also done for us. Okay, we are doing a great job here. After separating the classes from the measurements, we also need to split the data into training and test sets. So training sets is initially fed to the machine learning model, and this allows the machine learning model to learn and identify patterns that can be used for future predictions. So we are using a ratio of 80-20, meaning that 80% of the data will be used for training and then 20% will be used for testing. So that is what this code here is doing for us. So we are using the sklearn model selection train test splits. So that is what we do here. Okay, so let's run this. Okay, that has also been done for us nicely. But so far we have been running the codes just like that, but I think it's also good we just do some queries ourselves here. So I'll just add some code here. I'll just click and insert the code here just to check and verify some stuff here. Sometimes, even though you are in the codes, you need to also do some verification. So I'll just here just check some of the data points here. So I'll say xtrain the shape just to see how many samples are in the training sets. So I'll just run this code here to see. So it's what? 614. This number here should be the same for the Y train. So let me just insert another code here and say ytrain.shape just to get that. Okay, so that has also been done nicely for us. So we are good to go. So let's move on to the next code. Yes, so we are in the next session, which is standardization of the data. So with machine learning, sometimes you may have your data sets, the columns, okay, the values will be in different ranges, okay, so if they are in different ranges, it becomes very problematic because it will affect the models, okay, so this may also lead to bias in the models, okay, so the models may even think some columns contribute more than others, and so it is important we do standardization, and one of the ways to do this is to scale the data so that it's between 0 and then 1. If you take a look at the data here, let's look at the first 5 rows. You see that they all have different ranges. Okay, some are in hundreds, some are in tens, some are in ones. So that's what I'm referring to. Okay, so we need to scale them so that they are all in the same range, and that one will level the playing fields. Okay, so that is why we do standardization. So it is important you know this. Okay, so let's do the standardization. So I am using the min-max scalar in scikit-learn. So this is what I have here just to do the standardization. So I will standardize, and then I will also give those values. I will assign them to these variables here. So that is what we are doing here. So I'll just run this to scale them. Alright, so we have scaled them. So let's just verify. Let's just look at some of the data points here just to confirm that the scaling has been done. So let's insert a code here and let's run it. So let's just say x train scale. It should be the same shape as what the x train. So let's run this. Okay, so I just run this here just to see. So you'll notice we have the values here 0.176, 0.53, etc. So that's what I'm referring to. So this first point here is what is here. Yeah, what is here? This one here. So here it was, here it's 6. Okay, here it's 6, but when you come here, let's scroll down. When you come here, it is 0.1764. Okay, so that is what I'm referring to about the scaling. So scaling has been done properly for us, so it's good to go. Okay, now let's proceed. So everything is on track. So once we have this, the next thing to do is to train the data. So that is the training phase. So the training phase is where we feed the data with the training subsets and allow the model to learn from the patterns and use those patterns it identifies for future predictions. So that is what we are doing. Here I have two classifiers. The reason why I have two classifiers is that, remember I said ROC curves are generated using probabilities. So the classifiers have different methods for extracting the probabilities. So some will use the predict proba method, some will use the decision function method. So I just thought I would give scenarios for both cases. So that is why I have these two classifiers. So we'll look at how we do this. So let's run this. So with the classifiers, you have to initialize them by calling them. You have already imported them, and then you just fit with the training data, the X and Y, and then also you can also get the predictions. That is what I've done here. Okay, so predictions for the test sets, that is what I have here, and then the probabilities, that is what I generate here. So there's the random forest classifier. I'll just run this. Okay, that has also been done nicely for us. So let's run the same thing for SVM, support vector machines. So let's run this and get it going. Okay, that has also been done nicely for us. So now we have our train data. So now we can generate the ROC curves. And so with the generation, there's a function here that I have written just to automate some of the process. Okay, so that's what we have. So the function will allow us to reuse the codes as many times as we want. So with the function, the ROC curves, remember I made a brief description. I said we have the x-axis to be false positive rates and then the y-axis to be true positive rates. Okay, so we get these ones here using this ROC curve method here. But if you look at this function, you need to supply this function with two inputs, the y-tests. Okay, that's the outcomes for the test subsets. And then you also need to supply this function with the probabilities. Okay, so these are the placeholders. So that is what we use this one for. So this is how we're able to reuse the function, because we just need to call the name and just give it these values here. So you can actually apply this function if you have a similar data set. Once you have gone past that stage of splitting and training, you can just apply this function with your data set as well. So you can just experiment and just see how it goes. Okay, so we have the FPR and the TPR here. So now we can do the plotting. So with the plotting, I also labeled the plot with, I think, the AUC value. Let's go back and just check that out. I think it's supposed to, let me just open it here for you again. Let's see. I'm trying to open it here. Let me just open it here. Okay, I think it's supposed to be there. Let me open in a second. Let's see. Let's check. Okay, so this was a label, the AUC, that's the area under the curve value. So this one gives a summary of the performance of the model. So that is what we are computing here. Let's go back here. That is what we are computing with this one here, ROC AUC. Okay, so that's using the FPR and the TPR to do the computations. So that is what we have here. So once we have it, I'll just print it so that we know that's what the statement is. So after that, we will just do the plotting. So we'll plot with FPR on the x-axis, TPR on the y-axis, and then we give the label, which is the AUC value here. Okay, and we also customize with a color here, which is available. After that, we need to specify the location of the legend. So let's go back to the ROC curve plot I showed. So notice where it is. It's lower right. Okay, so this is what this code is doing there. Legend here is doing. So the legend here, we specify the location, which is lower right. That is what it does. We also need to plot what you call the no scale. This is the one, the plots on the plots from the corner. This plot here, this one here is the no scale line. Okay, so that is what we are doing with this code here. Okay, we also give some limitations, x limit and y limit, just to look at the limits of the values that Python should plot. So it shouldn't go below or beyond a certain threshold, and that is what we are specifying here. Okay, after that we give the labels for the false positive rates and true positive rates, and then we just show the plot. So that is what this function is doing. So let's run this function and proceed. It's a function, alright, but it's not going to give any output because we now need to call it. Here we just created it by running the code. So now we will call this function for each of those classifiers, and that is what we have here. So when we are plotting the ROC curves for random forest, we call the function by its name, which is plot ROC, and then what do? We supply it with the y-test and the probability. Okay, so the probability, I made mention that different classifiers will have different ways of doing the extraction. So that is what this does here. So let's run this. So let's run this to get the ROC curve. Okay, so nice one. We have the ROC curve here, and the ROC, the AUC value is 0.80. Okay, so let me also use this to quickly explain the AUC. Okay, so a model with AUC nearer or closer to 1 is a model which is performing very well. So that's a good model. That is an indication of a good model. Okay, so this means that the model is able to distinguish or is able to predict correctly the outcomes. It's able to do a good separation of the outcomes. That is what a good model will do. And so the AUC closer to 1 will indicate as such. If the AUC value is closer to 0, that means the model is not good. Okay, it's performing poorly in terms of being able to distinguish between the outcomes. But here it's 0.8, so it's close. It's a good model. Okay, so let's plot for SVM, and then let's see how it goes. So we have SVM also here. Okay, so we have it here. So with ROC curves, it even allows you to compare the performance of different classifiers, as I'm doing here. So with ROC curves, I've been able to plot the curves for 2 different classifiers. So we can use this to decide or make decisions as to which classifiers to proceed with. So that is what you need to understand. It is also important to check the steepness of the ROC curve. Okay, sometimes it's useful to check so that you have a better understanding of how the model is performing. But these things, just read about them. I'll leave some useful links in the discussion box. So let's proceed. Now, if you take a look at this function here, it requires that you compute or you extract the probabilities, okay, using different lines. But then what about if you automate this function so that you don't have to do those calculations, you don't have to do the extraction here anytime you call a classifier? Okay, so that is what I am making it here. I am making the function more generic. And so what I do here is to add these lines here. So these lines here just queries the model and checks if it's using this attribute, decision function. If it's decision function, it uses this code to get the probabilities. If it's predict proba, it uses this code to get the probabilities. After that, the rest of the codes remain the same, and you can get our ROC curve. So let's run this. Okay, so we have it there. Now let's proceed. So with this function too, we'll just use that to plot the ROC curves using these commands here. So let's run this to get it. Okay, so perfect. We have the ROC curves. Okay, so let's run this. We also get it here. Perfect, we have them here. So with this function, we supply it with the y-test and then the s-test and the model. So that is what we do, and then Python will take over. So that is what we've done. So I believe this tutorial has been helpful because finally we've been able to do some generation of plots, which is very important when it comes to machine learning. It's important to know how to evaluate the models, and we've done such here. Okay, so I'll also be very happy if you can give your comments and suggest how to improve this tutorial, because these are things we do for beginners and people who are interested to learn machine learning activities. Okay, so that's what we do. So that will be all for this tutorial, and if you are interested in other useful tutorials, I'll just leave some videos here that you can just watch to continue your machine learning work. So thanks for watching the video, and expect another tutorial on ROC curves. By this time, we'll look at how to generate ROC curves for multi-class situations. So that will be all. So see you in the next session, and goodbye.